Good afternoon, everyone. Welcome to the Tech Hub. This is a continuation of our series on sort of technology awareness. So this week we've got Andrew Edwards, who's going to talk us through an introduction to big data. Over to you.
Thank you. So yeah, I'm Andrew Edwards. I work in the data analytics delivery group, where over the last sort of 3 to 4 years we've been working with HMRC on building the Enterprise Data Hub, which is basically a big data platform. Sort of my experience around big data has been over those sort of 3 to 4 years. So this is a sort of a history around big data, a bit of an introduction around some of the tools and technologies and the reason for it, and those sort of things, and then a little bit around the Enterprise Data Hub EDH and some lessons learned around that. So yeah, just a little bit of coverage of what is big data, an introduction to MapReduce, some of the sample technologies, and then, as I say, go and have a look at the EDH and what big data means for HMRC. Okay, so what is big data? So this is the sort of dictionary definition. So in short, it's around data where the amount of data you've got is so large that it becomes very difficult to use traditional data processing applications. So the sort of the classic example is the Large Hadron Collider, which is generating 41 terabytes a day, half a gigabyte a second. So that's a lot of data. And because of that, and because of those sorts of data volumes, especially through the larger organizations like your Googles and your Facebooks, where you're collecting sort of a wider volume, but also wider variety, things like weblogs, things like a lot of unstructured data, which are the sorts of data which you'd fit into a sort of more traditional processing model. And the amount of and the velocity, the amount of the speed that the data is hitting you is quite fast as well, and that's where sort of big data comes in, and why that requires a different approach. So in 2004, Google published a paper on a process called MapReduce, which is a concept which talks about a parallel processing model of how you can process a huge amount of data. So the idea is all about parallelism. Okay, so I've got my whopping great big data set, which is my 100 terabyte weblog from every person that ever accesses a Google web server, and I want to process it, and it's just so large that there's no way that I can process it using traditional methods. So the MapReduce paradigm that was wrote about in the paper talked about splitting the job up into 2 logical steps. Okay, the first was a map phase, and the second was a reduce phase. And the idea was that you could split that whopping great big file up into chunks. And first step of the phase would be the map phase. So you would map the chunk of that data in some function, depending on what it is you want to achieve from the data, massively parallelized onto many, many, many servers. Okay, so this is a word count example. So the problem is I've got a whopping great big file, and I want to count the number of instances of each word in the file. So the way that we break that into MapReduce is the first is the map phase, where you map one word in each of the chunks to the number 1. Okay, so you've mapped that massively parallelized file, and what you're left with is each of those words with a 1 next to it. Okay? Then you want to go into your reduce step. So you want to then take all the words that are the same word and collate them up. So there's a sort of a shuffle and a sort where you're collating those common words up into the same thing, so you've got the same, and then you go down to the reduce phase, which again is massively parallelized. So you can run that reduce phase onto multiple servers to arrive at your final result. Okay? So that is a sort of a theoretical workout example of how the map reduce paradigm works. So that paper was published, as I said, in 2004 by Google, and it was that framework was so successful that others wanted to start implementing it. In about 2006, Doug Cutting, who was working at Yahoo at the time, used the MapReduce framework to create something called Hadoop, which was named after his son's toy elephant, hence the elephant. So Hadoop built on the MapReduce paradigm, but it also had to deliver a way of storing files. So MapReduce was just a concept. It was just, okay, if you had a massive great big file, you could theoretically do any type of processing by doing a map and a reduce and a map and a reduce and a map and a reduce, and process the file in that way. And any logical problem could be split into those two processes again and again. But what Hadoop did is it took that concept and it said, okay, so that's how I process files, but how do I store files? And so it said, well, okay, I need to be distributed, obviously I need to distribute my data across multiple servers, but I also want to be scalable. Okay, so I want my solution to be designed such that I'm saying that I've got all this data, I'm saying the data's coming at me fast. What I want to be able to do is easily scale up the solution very quickly without worrying too much about how I reorder or replace the data. I just want to be able to scale up quickly. And I want to be fault tolerant, which will come onto the next slide. Yes. So what Hadoop did is it also introduced HDFS, which stands for the Hadoop Distributed File System. Okay, so rather than files being thinking of one file sat on a machine, it's a distributed file system. So that one file is split across and distributed along the web. So let's say in this example you've got 8 servers, and the numbers represent different segments of that file, of that whopping great big 100 terabyte file. You've got different chunks of that file spread across the cluster. But when you implement parallel processing, let's say you're processing a file, and you've got chunks 1 and 4 on there, because both 1 and 4 exist on the same node, I can't parallelize them, because if I'm processing this one, I can't process this one at the same time. So what I'm going to do is I'm going to also replicate the data. So 4 is also going to be stored on this server, and 4 is also going to be stored on this server. 1 is going to be stored on that server, and that server. And what HDFS delivers you, the file system, is when you're running your MapReduce job, it'll say, okay, well, I've got multiple copies on multiple servers, so we'll run the map process of segment 4 on here, and we'll run the map process of segment 1 on here, and we'll run the map process of segment 2 on here. And what it's there to deliver is complete parallelism and flexibility on where you run the processing. Okay? And what it also gives you is fault tolerance, which was the second thing. So if this server dies and goes out of service, it's okay because I've got another 2 copies of that in other places. So I've got fault tolerance, and so the way it was designed was it was designed to be run on cheap hardware. Okay, so and it adds to the scalability as well, because it means that I can just spin up an extra 50 servers. They don't have to be really expensive, high performance. They can just be 50 servers that I bang on, and they'll give a little bit of extra brute force to the server. And if one of them goes down, it's fine because I've got So that's what HDFS delivered. Oh, sorry, I'm sure I also mentioned about data locality. So one of the most important things about we're talking about the map process, it's really important that we try and reduce the amount of moving over the data all across the nodes. This shuffle and sort is inevitable. If you're looking to do a group by, you have to at some point group the data. But you want to try and reduce the amount that you're moving the data across as much as possible. And so by keeping data local to the node that you're doing the processing on, you're reducing the amount that you're moving the data all over the place. And so by having that replication, it gives you that flexibility and that data locality. So in the beginning, MapReduce was written in Java. So to provide the MapReduce function, you would write a map function and you would write a reduce function. So the map function would be executed on every row of the file. And in here, like we did in the example, we're taking the row and we're splitting it up into words, into tokens, and then we're writing out each token with a number 1 next to it. And then when we're reducing, we're saying, okay, for every word that's the same, sum up how many there are and write out the sum. So that basically is the Java implementation of the word count example of how you would implement MapReduce. Okay. So just a bit of an interesting backstory. In 2010, Facebook had the largest Hadoop cluster in the world. So they had 21 petabytes of storage in a single HDFS cluster, 2,000 machines. They had 12 terabytes per machine, and you can see that they just, they completely. It all sort of scaled up around sort of 2009, 2010. So, HFS and Hadoop really was the backbone of Facebook at that time. And it was implemented in that way. So, as Hadoop evolved and its popularity increased, an ecosystem started to be built around it. And rather than just referring to the MapReduce and the HFS, people started building other tools that added on and complemented those tools. And so Hadoop has then subsequently started to be referred to more as an ecosystem rather than necessarily Hadoop MapReduce or Hadoop HDFS. So I was just going to take you to a couple of the examples. I felt logically it would be worth talking through an example of how you bring data in at speed and how you process the data as well. So Flume, Apache Flume, was written as an open source product. Its initial sort of idea was around web server logs. So they said, okay, you imagine somebody like Google, everybody that ever accesses www.google.com. There's a lot of web server data there. There's a lot of traffic to ingest, millions, billions really, of web server logs. So Flume was written to ingest those web server logs and get them into HFS in a speedy way. So Flume consists of Flume agents, which are 3 main components. You've got a source, which is where you're getting your web server data from. You've got a channel, which is where it then temporarily stores its data that it's received from its source. And you've got a sink, which is the point where it's delivering the data, in this case HDFS. So as Flume evolved, it added extra functionality, but the key ones were things like the spooling directory source, which is basically log files coming in. So you can have in-memory channels, file channels, depending on how resilient you wanted the data, and then into the HDFS sink. But as I said, more and more were built over time, depending on how you wanted to get your data in. So this is just an example of Hadoop source. So this is how you would write your Flume agent code. So basically your Flume agent, you want to get the web logs from this particular directory. You want to then store them in memory as you receive them, and then you deliver them out to HDFS. So to give a real life example, if you, I'll set up the slides after, but if you go to this link, it talks about how you can ingest 1 million events a second using the Flume and Kafka technology, which is a similar sort of event streaming thing. So it just demonstrates there the potential of that technology and how you can bring in those size of data into Hadoop. Okay, so as I said, Hadoop was pretty popular, but you've suddenly now got a lot of people that maybe, especially when they come from traditional data processing methods, things like SQL, Oracle, database things, suddenly now they're all having to write Java code, which is a bit of a leap from SQL to Java. And so Facebook started to develop Apache Hive, which gives a sort of an SQL-like interface to MapReduce queries, and it provides a sort of an SQL-like abstraction so that you don't have to write the underlying Java code. So it gave two key benefits. So you've got HLS, you've got all your files, and you've got your MapReduce as a processing method of doing those. Hive delivered these two key benefits. So the first thing it said is, well, if I'm going to start running queries, SQL-like queries, I'm going to need something to run those queries on. So I'm going to need things like tables and databases and all those sorts of things. So they built the Metastore, which allows you to, instead of thinking of just a file system and just files, it starts pointing to tables that exist as files on the file system, and then allow them to be formatted in a certain way, and so that rather than you having to worry too much about how you're writing your data or reading your data, you just see it as tables. Once you had that, it was then able to start doing sort of high-level abstractions to MapReduce, so that, again, keeping with the word count theme, somebody could just write this, which would be the Hive code that you would write, which is an SQL-like form, which would then, in the backend, get converted into MapReduce code for you to execute on the data, to execute on the files. So, going from that Java code that I showed you earlier down to this sort of 5 lines of HQL was obviously a welcomed progression, and that made things much easier to move for things like DBAs and sort of SQL experts to do that. So just some examples there of people that are using Hive, just taken from the Hive website. So eHarmony got a 640 sort of server cluster, and they're all using sort of Hadoop and Hive technologies. Okay, so that was sort of in around sort of 2010 to say that Hive was developed. So then, over the years, it was noticed that one of the downfalls of Hadoop was it was a very disk-based processing. Okay, so you'd have your input files, you'd read them, then you'd write them. You'd do a map, and you'd write them to disk. Then you'd shuffle them, and then write them to disk. Then you'd read them, reduce them, and then write them to disk. So if you're doing lots of MapReduce processes one after the other, there's a lot of disk-based processing, that takes quite a lot of time. So Spark was developed in 2012 in response to some of those limitations, and the sort of the force of MapReduce phase. So by using sort of more in-memory processing, but also optimizing some of the sort of simpler operations that MapReduce had to do, it generated significant sort of speed increase of a lot of the processing that MapReduce was doing. But and it also built on and opened up sort of APIs in various other languages, including things like Scala and Python, which I think were growing in popularity at the time, and subsequently R is also now supported. And what it also did is it didn't just have MapReduce, it also started to support some of the sort of machine learning and graphing sort of things. AI started to become more and more popular, and sort of, as I said, machine learning, those sorts of things. And it's, in 2013, it was subsequently donated to the Apache project. So again, Apache Spark is an open source project along with all the others. And also quite interesting that Apache Hive, which we talked about, because it was a high-level abstraction of people just writing Hive code, and behind the scenes it would turn it into MapReduce, they subsequently rewrote the code so that instead of turning it into MapReduce code, it can now turn it into Spark code, which then allows you to continue using Hive just like you always have done, but using Spark as a processing engine rather than using MapReduce as a processing engine. But even to this day, Spark's one of the biggest or most active open source, particularly big data projects. So I should say I've taken these slides from a Spark summit we went to a couple of years back, and they described it in this way. Now I will say that the people that did these slides were from the company that invented Spark, so they are slightly biased, but nonetheless I think it's some really nice slides. So they took it this way. They said, look, you started off with your basic mobile device, and it was like, the greatest invention ever. And then all these sort of specialized devices come out. When you have about 5 different devices in your pockets, you used to have your little PDA and your MP3 player and your GPS and your MP3 player and your phone, and all these sort of different devices. But no, we don't have all these devices. We just have a smartphone, and it can just do everything you want it to do. Which then naturally means that everything starts to get better and better and better, because everybody's working on one device, everybody's working on either Android or iOS, none of those, which leads to further improvements because people can focus on improving technologies. And the people at Spark felt similarly. They said, okay, you started with MapReduce, that was a great big invention. But then what came out of that is, okay, well, I want to sort of do this, I want to do sort of machine learning, I sort of want to do graphing, I sort of want to do more performing queries, and all these different specialized systems came out. But the people at Databricks feel that Spark is that unified system. So why do they think that? The key argument was around unifying data sources and data processing. So MapReduce runs on HFS. That's just what it does. That's what it was built for. That's just it. Spark is an independent storage layer. So Spark can run on HFS. Remember, HFS wasn't necessarily about MapReduce. HFS was just a file system which allows you to store files distributed. So Spark built in the ability to process data on HFS, just using the Spark processing model rather than the MapReduce processing model. But you can also run on things like Oracle databases, Cassandra NoSQL databases, and all that kind of stuff. So it's independent of storage layer. You can use Spark on your data even if it's not on necessarily, say, a big data or platform at the moment. But also, the data sources that you can read are varied. So it has built-in support for things like Hive, HFS, but also things like MySQL and JDBC. So you can write your code and say, okay, well, I want to pull those big data, but I also want to pull some MySQL database, merge the data together and do that sort of processing. So it was in that sort of flexibility that they felt they had that edge. But in addition to that, not only does it have that flexibility, but it also builds on some other key concepts. Spark streaming is a similar sort of concept to, say, Flume. It allows you to stream the data in. MLlib, machine learning, so there's built-in support for machine learning algorithms within Apache Spark, and GraphX again allows you to do graphing. So it's a tool that allows you to do many things, not just process data. And it also has built-in SQL support as well, so full SQL. So I just wanted to sort of show an example, just maybe put it in life. So British Gas, I don't know if everybody's got a Hive. How old this is? This was 2 or 3 years ago. But they use Spark streaming to stream all the data from the Hives people home into a Cassandra database, and the Spark's then used to process all the data from the Cassandra database to allow that analytics to be available to you on your mobile phone. which I think is pretty cool. So I just put some links there if you want to learn a little bit more about Spark. Okay, so what next? I'm hoping this link will work. We had some database issues, access issues before. Not much we have to use there. Yeah, I just thought this was quite interesting. I don't know if you've used Google Trends before, but you can put in certain search terms that will tell you how often those search terms have been used. It sort of gives you an idea of the popularity of these sorts of things. So this is over the last 5 years. So the red, I think, is Apache Spark, yeah, and the blue is Apache Hadoop. So you can see if Hadoop's got a pretty constant sort of, and there may be a little bit of a tinkering up over time, and Spark's just come over the last 5 years and just sort of done that. I don't know what happened there. That's what the Spark Summit we went to. But I think that's pretty cool. So I think the other ones were, yeah, Apache Hive and Apache Storm, which is another one we haven't talked about. So again, a pretty constant sort of view. I just thought that was quite interesting in showing how Spark's sort of taken off a little bit. But Hadoop is still there. Remember, Spark can run on HFS Hadoop, so even if sort of MapReduce, Hadoop MapReduce starts to tail off, HFS is still quite popular. Okay, so that's a sort of a view on the technology side of things, of how things have gone. So now a little bit more about sort of HMRC. So what does big data mean for HMRC? So I've been told that the HMRC warehouses that we manage with DNA have a total volume of about 160 terabytes total across all the things. So there is still some debate around whether that constitutes big data or not. But I think when HMRC first sort of made a choice to go towards Hadoop, I think they liked the buzzwords. They liked things like scalable. You know, the idea that we could start bringing in data and we could just get bigger and bigger and bigger. There was no limits. You know, we didn't have to worry too much about, you know, the sizes. It's, you know, it's something that potentially unrestricted. Open source, maybe that's going to be cheaper because, you know, you don't have to pay massive licensing costs. You do then have to pay support costs, which can then be just as expensive, which is, can make things. But cost-effective storage as well. I talked before around how one of the ideas behind HFS is that it was fault tolerant, so you could add in multiple sort of machines. They didn't have to be top-grade servers. They just need to be servers that provide some root power. And so okay, that means I can get Hadoop is then cheap storage. But the question is whether you can plug into that cheap storage and actually use that cheap storage, or whether you know, you're forced down buying expensive servers from clients. So those sorts of things.
One quick question: does it help to link data to the different systems? Because I might be John Smith, Ecotex, John Smith, yes, John Smith. The system does Hadoop big data?
I think that's the idea. I think one of the words I haven't used in here is data lake, which I think the idea was, rather than having siloed this, you know, this warehouse and this warehouse, the idea was having a great big data lake where all your data is stored, and you could have unrestricted access to moving your data around. So I think that was definitely one of the things that, it says here, you know, siloed, fragmented vision, you know, up to, okay, you know, a great big warehouse of all my data. It's all there. You know, I don't have to go and think about opening up channels. It's all there and available to me. And I think that was definitely a sort of a positive that they wanted to sort of plug into. The other thing I should say is that you know, we've heard of sort of companies like Facebook and Google. They're the natural choices for big data. Yeah, I mean they've got so much data to work with. It's invaluable. Everybody uploading their pictures to their. It doesn't work that well for small data, right? So you could probably run billions of rows in a few minutes, but it also takes a few minutes to process 100 rows. Yeah. So just the way that the model is set up is like that. So if you've got a mixture of big data and small data, you're actually reducing the amount of, increasing the amount of time you're processing your small data to facilitate the big data. And that's how, it's not, you've got to fit into that sort of section of people using big data. So this is it. This is the Enterprise Data Hub that we built with sort of Fujitsu and Cloudera. Just to put a little bit of context, so Hadoop, HDFS, all open source, okay, freely available, all open source. But then naturally what happens is that companies say, okay, well that's all open source, okay, but do you know what, I can take that and I can make it pretty for you and I can package up the little pieces and I can not worry about version control and all that kind of stuff. Because one of the bad things about open source is you've got all these different tools. It shows you the ecosystem of Hadoop, right? So you've got about 20 different tools, say. And managing all those dependencies and versions, all that can become quite cumbersome and quite difficult. So companies like Cloudera make it easy for you. So they get all those different open source tools and they package it together and they say, well, this is our version of Hadoop, but of course that comes at a cost as well. So with Cloudera we support Cloudera Hadoop version. We build EDH. We're using tools like Hive to do data processing and ETL. We're using tools like HBase, which gives a more real-time processing. So for example, Hive is for massive batch ETL processes. So I've got 1 billion rows, and I want to process them. I've got 100 billion rows, and I want to process them in batch. But that doesn't work so well if you've got 100 billion rows, and all you want to do is access one row to send back to your web server. Yeah, because you don't want to run a 5-minute process when you just want to get one row. So HBase solves that problem for you, and it provides it's the NoSQL database, sort of Hadoop database, and it allows very quick access to single rows or multiple rows, massively scaled up, 100 billion rows, so access. And then on top of that sort of Hadoop cluster, we've got sort of various applications for viewing the data, things like Spring Boot to have access to the data using HBase and SAS and all those sorts of analytical tools. Any sort of questions around EDH? Okay.
Why did we use Spark?
Why didn't we use Spark? So Spark, certainly at the time that this was delivered, I think was still a little bit evolving. I think it tends to take a while. What we found is that particularly for open source technology, it takes a little while, and longer than you might think, for them to become what they might call production ready. So for example, it was only on the recent upgrade that we got where it was deemed that Spark as a processing model for Hive was production ready. So in the last month, we've got an upgrade now which as I said, allows us to switch in Spark as a processing model. There are tools that we built in Spark over the last few years, but there are tools that we built in Spark. As I said, a lot of the stuff we built is in Hive, so by swapping in Spark as a processing model, we can get that benefit straight away. So just a couple of lessons learned from the 3 to 4 years we've spent on the EDH. So data isn't just data warehousing. So I think the business case that was formed around the EDH I think the value in terms of how the top level sort of management saw it was the value of bringing all this data into a data warehouse, into a data lake, and having that all in one place. There surely is huge value that can be gained from that, and being able to have unfiltered access to all that data. But a business case had to be put together for the approach, and I think that business case, when it was put together, was around the migration of services, many of which were on sort of legacy support and those sorts of things, onto the EDH. And that kind of led to a criticism of the EDH not delivering enough business value because migration of the services wasn't necessarily delivering the massive sort of revolutionary financial benefits that we saw. And so I think we could maybe spend a bit more time looking at the data as we bring it in and proving that business value. And then once that's proven, start to industrialize that rather than just focusing on bringing all the data in and trying to store as much data as we can. So I think that's definitely something we've learned.
So what benefits have HMRC?
Good question. So IXBR is the obvious example, but I couldn't do.
So they've seen some benefit bringing the data together, and I think it's stimulated them to start to think differently. But the benefits have been nowhere near the cost, which is the opportunity.
Hence the lesson learned of spending more time looking at the data and we try to sell that to them and say, look, if you just spend some time just sort of looking and analysing your data and doing a bit of data science stuff on it, and we think that you could really get some business value. Unfortunately, we haven't been able to sell that as much as we could. Right tool for the job. So, just because it's big data doesn't have to mean just one great big monolithic platform. It's about the right tool. So it was quite technology driven. So it was, we're going to use Hive, therefore we're going to use Hive for everything. And so in some cases we had projects being pushed towards some technologies because of that overarching approach, rather than it being necessarily the right tool for that particular job. So I think that's a lesson learned, and obviously security constraints has meant it a little bit tricky to prove that business value because of the restrictions that have been put into place. So interestingly, when you talk about security, certainly things like sort of the conferences, they're always saying, the best thing to do is just to strip all the personal data from the data, and in that case, it makes everybody happy then. But we're not always able to do that, and a lot of the stuff we're doing is very personal, and so that can. I think we've been hit by a lot of security issues that typical companies looking at data science and that don't necessarily hit it as much. That's it. That's all she wrote. Any other questions?
Is HMRC continuing to invest in the EDH as?
I think the decision to store or to move all the warehouses into one single platform, i.e. the EDH, is no longer their strategic vision.
That's, I guess, a lesson learned because they did not see the benefit they thought they might get in the first place.
Hence, I think the first.
But are they investing in something that is going to give business value, or are they kind of abandoned it now?
They haven't abandoned it, so they are still getting some benefits from that platform and some of the services that sit on that platform, and they will continue to exist, particularly around some of the ingestion of third-party data, because they have to, because tear down the previous of how we used to ingest third-party data. So yeah, so most certainly there is still services that are up and running and that are required, and they will continue to exist. But I think that just the general vision that everything will just get migrated across to this great big platform has changed.
How much of the data was actually ingested? If we had, I don't know how many, but let's say we had 10 data warehouses before, how much was actually put into
That's a good question.
a subset of that? Or?
So the majority of so what we did is, instead of, we split the feeds, so every feed that was going into the existing warehouses we split and fed into the EDH as well.
Right.
So the majority of those feeds now go into both services.
Right. Okay.
Is there anything more from the Gartner report that we'd sort of acknowledge, agree with as lessons learned? That if we did this again, we'd do it a different way?
That's a good question. I personally haven't seen it, but yeah, something I guess we could. I think
what they are doing now is they're using what they've learned in building the EDH, and they're now trying to focus it. So, for example, for customers and Brexit, they're probably going to build a cloud-based analytical service. So rather than building it on the EDH, they're going to build it on a sort of like an AWS service and make it smaller and focus purely on servicing that particular requirement, because they've learned that they can move the data around quite quickly.
Right, but that's probably an opportunity that AWS gives us that probably wasn't there when we started. I just wondering if there's anything we started. I have to say, looking from the outside, the idea of we should have thought about consuming the data and using the data before ingesting it all really seems obvious as a lessons learned.
Well, they knew that at the time, but
why they kept on doing it is a puzzle.
Their only funding mechanism at the time was to
Get it
reduce
removed,
costs,
because that was their business
to
case.
get rid of their existing warehouses.
Yeah, okay. So the business case
So they
was the
knew,
fault, really,
to be
wasn't
fair,
it?
they knew that, but obviously they had to get funding.
I completely
Yeah.
agree.
They should have said stop earlier, I suppose, is what it's, but yeah.
I think the business case was arguably wrong.
Yeah.
And I think, bizarrely, they knew what they wanted the benefits to be, but they needed a business case, and I don't know why that couldn't have been the business case, but for whatever reason it was.
So what does the deployment topology look like at the moment in terms of infrastructure, data centers? You mentioned moving to cloud, so I infer it isn't on cloud at the moment.
It's on fast.
It's on FastDA at the moment. So it's a Fujitsu delivered Red Hat 7. We've got a 28 node cluster of Red Hat 6, soon to be Red Hat 7 servers, with a bunch of bits around it. But yeah, FastDA Fujitsu network.
And SDCL on to it. Is that right? Steve, actually.
And we've got a production environment for beta/live, and a pre-production environment, which is a 3-node cluster for sort of alpha testing.
You mentioned security and SCRs. That was always an issue.
Massively,
How to deal with them.
yes. Both in terms of delivering a security solution and in terms of then subsequent using of that security solution was certainly a big challenge.
They get benefits from 0.03% of the data.
Yes, roughly that. Yeah.
Have they solved that though? Did we get past that problem?
A security solution was delivered, which is now causing huge amounts of pain to anybody trying to ingest data into the platform.
So does that mean no, we didn't solve it?
Well, yeah. Probably not. No, not in the. I think that there was. I think over the last year, I got fed up of people telling me that we're the only ones to ever do this. Do you know how many times? Oh no, nobody's ever done that before, or no, none of our other clients want to do that. And security definitely was one of them. I don't think people just don't try and tackle that problem. The traditional solution was just to filter it out.
Yeah,
and that's job is good,
that
and that's your point. Whereas their solution was encrypt all the data, put various security controls around the data, and that just makes it harder and harder to get at the data, and harder and harder to have performance and speed and all that kind of stuff.
So apart from Spark, what are the other big players out there in this space?
I mean,
So you have Mongo, Yellow Suite.
say again, sorry.
Same with Mongo these days.
MongoDB, yeah. I mean, I think that there is. I was going to say quickly, but I don't know if it's. I don't think I'm being videoed. Yeah, I think there is some. I'm afraid. I think there is definitely a lot of people saying, well, how many people actually have big data? I know I've just gone through the whole presentation, but how many companies? Clearly Facebook do, clearly Google do, clearly. But I think that people see it as such a sort of exciting sort of technology thing that I think people are driven towards it without necessarily having that big data need. Now something like Mongo, which is a fast, scalable, NoSQL solution, you might not call it big data, but you would call it a massively scalable, almost sort of like Cassandra or whatever, massively scalable data solution. I think they've got a massive role to play. But yeah, I think from a big data perspective, I think Spark, and there's a couple of other things like Apache Storm and that, but I think Spark seems to be the biggest player at the moment. Spark is the one that people tend to talk about quite a lot. Do you have a question? No, it was you.
What sort of insights were HMRC looking for those insights into that big data? Was there anything particular? And one was what you just said, is there enough data to get those insights? Because a lot of people on Facebook and Google, but Facebook and Google can do things no other company can do at the minute, and companies keep trying to do it, and it doesn't want to say don't have the data. So do you think HMRC actually have the data they needed to get those insights?
I think they didn't necessarily have the data, but I think the dream was that if you build a scalable platform that you could put data in, you could then acquire that data. And I think there are data sets that they could acquire. Stupid little things like they were talking about the HMRC web server logs, the systems around doing some data science around when people access the websites, which buttons they click and how they navigate around the websites, and how that maybe could infer people's user experience and all those sorts of things. That data is not necessarily being ingested and readily available now, but it's something that I think that they had, they envisioned as the kind of data that they could tap into, and if there was a scalable platform, big data lake that they could put data in, it opens up all those potentials. So I think there was the potential there, but I don't think they necessarily got there yet. But I think they could have done, or could do.
So most of those technologies are not ingested in data. Would you then in the future look to add on other software to do that analysis? Or I can see some of the add-ons like graphing and stuff. Is that sort of enough, or is there other stuff you would want to add into the stack?
I think from a data science perspective, Spark gives you quite a lot of the machine learning libraries and that kind of stuff that data science would need. It also, there are also things like Python, and it's very easy to build in just deliver extra Python or R libraries to the platform. Spark has a R API now. So you can write a Spark job in R, which pulls the data from Spark, from the EDH cluster, and then runs a bunch of R machine learning data sets and all this sort of stuff on it. And you can't get more, data sciencey than R, really. It's that itself is going to. I'd like to stick along the graph actually to see how much that's. Although I don't know, R is quite a difficult search term, but yeah, I think there's definitely potential there. I don't think it's a technology limit.
I think their initial objective was to find something that their analytical teams could use and something that their end users could self-serve on. So they focused a lot on better and SaaS. But other third parties, including Capgemini, have already started using other tools to sort of show them how we could exploit that data, and using AI to show them how we could exploit that data, where they allowed us access. That's the hardest bit, is persuading them to allow us access to the right data.
What about skill sets, that sort of thing? So data scientists, analytics, insights.
So we're using insights and data as our data science consortium, and they're linking up with our AI teams in the UK. So we're bringing people in to help us. But our own people are then, so what we've got to work out is how does an engineer work in that environment? It's very different to being an engineer in the classic environment.